Okay, so hello. So good afternoon, everybody. So what I started to explain last time, Boolean logic operations. I told you we have instructions to do logic AND, logic OR, and logic XOR. Okay, so it bitwise, bit by bit AND, bit by bit OR, bit by bit XOR. Okay, and also I explain our so let's go to this. So these are the instructions we have here. Okay, so we have AND A, and then we have here, you can put here immediate value or memory location. So what this instruction is doing is you do logic AND between immediate value or memory location, a byte in memory location with register A, and store the result in register A. So you have two bytes, bit by bit, you are going to do AND operation. Okay. So we have another one for register B, as we see here. Okay. Also, we have another one for the flag register, as you see here. So that's all what we have. We have 3 instructions for AND. All of them are 4 bytes. Okay. Again, if you want to do it for a word, it's that difficult? No, it's not difficult. You know why? Very simple. Because if you have a word, you can do byte and then byte. There is no carry I can worry about. You got what I'm saying? So if you have a word, here, guys, and then I want to do AND, logic AND with another word. Okay, here in this case, I can do 2 separate operations. I can do one AND here and another AND here for bytes. It should be okay. Why? Again, this was not okay in case of addition because there may be carry you need to worry about. Here there is no carry. Anyway. Also for OR logic OR, so same thing. We have exactly same instruction, guys. You can do OR logic OR for register A and the memory location or immediate value, or logic B. Here register B, or same thing like this one, also flag register. Okay, and this one's for bytes. By the way, when I tell you memory, it means any format that for the memory I explained before. So it can be 1000, it can be 0, x, it can be a, x, it can be 1, x plus. Any one of these should be okay because this is a byte, not a word. Is that okay? For XOR, it's the same thing. However, there is a small difference. In case of XOR, also we don't have this one. So we have for register A, we have for register B, but we don't have this one for the flag register, as you see here. Okay, guys. So these are the Boolean logic operation we have. These are the instructions we have. Is that okay? Now, any question? Is anything here is not clear? So this just logic operation, bit by bit logic operation. Okay. Any questions? Now, what's more important is how I can use this logic operation, and very important, very important. We're going to use them all the time. How can I use them? Okay. The way we are going to use them, guys, as I explained here, we are going to use them in 2 things: to do bit manipulation, also to check some bits if they are zeros or ones. So given a byte, that's exactly what we are going to do here. Very important. This slide is very important. We are going to do it all the time. So what I'm explaining here, guys, is given a byte. That's exactly what we are going to do all the time. Okay, I have a byte. I need to check, is this bit 0 or 1? I need to check. Okay, so that's what I'm going to explain here. How can you check maybe 1 bit, maybe more than 1 bit? So given a byte, how I can check some bits, bit or bits, okay, to check if they are zeros or ones. Is that okay? Why this is important? Simply because this byte, as I'm going to explain in chapter 3, when you read port, okay, so let me show you. as I'm going to explain in chapter 3, all the input-output devices here are connected to ports. For example, this is switches. The switches are connected to port H. So if you want to know if this switch is connected or not, to do some action. For example, if the switch is connected, run the alarm. I want to run the alarm on the, so I have to do something. So I need to check first to see if the switch is connected or not. If it's connected, I'm going to do something. If this is disconnected, I'm going to do something else. So I need to check. Okay. So what's going to happen is that we don't have we don't have an instruction to read one bit. So what's going to happen is that if I want to check one switch, you have to read the whole port. You don't have other option, right? So what's going to happen? You have to read the whole byte. Okay, even if you are only interested in one bit, yes, even if you are interested only, you have to read the whole byte. And then once I get a byte, I'm going to check if this bit, because I care about this switch. Because as I'm going to explain in chapter 3, as you see here in this picture, every switch is connected internally somehow to one bit, so that if the switch is open, so here in the microcontroller we have a pin here, external pin. If you put 0 volt here, the hardware is going to put here in this byte, in the port, is going to put logic 0. If you put here 5 volt, you are going to put logic 1. Okay, so again, to make it simple, in this case, you have to read the byte. Then after you read the byte, I want to check 1 bit or 2 bits, whatever we're going to do. So if I want to check one switch, so I have to check 1 bit in a byte. Okay. So how can you do that? I already explained. I already explained one way to do it. This is using branch shift clear, branch shift set. And today I'm going to explain another way. The other way is you can use logic AND. So now you have 2 options, guys. You have 2 options now to check if some bits are zeros or ones. One option using branch shift clear, branch shift set, which is easy and it's okay. However, it has one problem. The problem is this one, short branch. It's a short branch. If it's okay for you, just use it. It's okay. Just use it. Okay. But I'm going to explain another approach using logic AND to do the same thing. Another approach using logic AND. The good thing about logic AND, if you use logic AND, you can make the branch long, because this one is always short. You got what I'm saying? Again, I'm going to explain 2 approaches. As I told you in this course, guys, this is how programming should. I have to explain different ways in programming, right? And then if you can select whatever, as long as this one is working, okay, so you can just use this one. However, if you want to make like a long branch, this one is not going to help you, or maybe you have to do some trick, as I did before, to make it long. If you can't, you have another option. That's why I have to teach. That's why I have to teach the 2 approaches. Okay. So that's what I'm going to explain today here. The other thing also, how can we use logic operation? Also, we're going to use logic operation for bit manipulation. Again, what this means? What do you mean by bit manipulation? Very simple, very simple. I have a byte, 1 bit. This bit, okay, I don't want to change the other bits. So here, no change, no change. I just want to change 1 bit and don't change the other bits. So I have a byte. I just want to manipulate 1 bit, 1 or more, but some bits, maybe 1, maybe more, okay? And some bits I don't want to change. Is that okay? What do you mean by change? I mean by change, number 1, I want to set the bit. Number 2, I want to clear the bit. Number 3, I want to flip the bit. Very simple. That's what we call bit manipulation. So bit manipulation means I have a byte. How can I manipulate some bits and don't change the other bits? And manipulate means set, clear, flip. Is that okay, guys? Okay. Now, okay, tell me why. Tell me why we need something. We need something like that. I'm going to tell you why. The reason is, if you look here again, guys, can you see the LEDs here? LEDs. What happens is that, as you see here in the picture, every LED is connected to 1 pin on port B. Port B. Is that okay? Again, port B internally here, there is 1 byte for port B. Every time every time, and every pin internally somehow connected to one, every pin. So here inside the microcontroller, every external pin internally is connected to one bit on one port B. Okay. So what's going to happen is that if you put 0, so again, this is a byte. This is a byte. Is that okay? Every bit is connected somehow to external pin, so that when I put here logic 0, actually I'm going to put here 0 volt. When you put here logic 1, in this bit, actually you're going to put here 5 volt. You got it? So the idea is that, look at programming. I have a byte. Okay. Every bit is going to control one pin. What do you mean by control? Control means you put 0 volt or 5 volt, right? In this bit, if I put 0, you're going to put 0 volt. If I put 1, you're going to put 5 volt, right? That is why if I want to turn this LED on, the corresponding bit, I'm going to put 1 to turn it on. Because when you put 1 in this bit, actually you're going to put 5 volt on the pin to turn it on. You got what I'm saying? If you want to turn it off, the corresponding bit, you have to put 0. I'm giving you example, guys, why I need to do bit manipulation. Bit manipulation means I have a byte. In this byte, why sometimes I need to manipulate one bit and don't change the other bits, right? Because here this is port B, so you have to read. You have a byte which is port B. You got what I'm saying? In this byte, I'm gonna modify which LEDs I want to turn, and then I have to write a byte. Okay, we don't have an instruction to read a bit or write a bit. We don't have this one. It has to be a byte. So in this case, you have to get a byte and then it checks some bits. In this case, you have a byte and then you need to manipulate some bits, and other bits you don't know to change. You got what I'm saying? Anyway, so now the question is that I told you here, guys, if you want to check some bits, I'm going to explain 2 approaches. One approach I already explained. Maybe I'm going to make a very quick revision. A branch if clear, branch if set. The other one, I'm going to explain how can you use logic AND. Here, how I'm going to do bit manipulation here, guys. So let's explain. If I want to do clear set, if you want to set a bit, what instruction we have to use? Okay, for this one we have an instruction, guys. We call it bit set. This is bit set. Okay, that's a very good way. Or you can, as another approach, you can use logic OR. Okay, how can you clear? Okay, to clear you can use an instruction, we call it bit clear, or you can use logic AND. If I want to flip some bit, we have only one way. You have to use XOR instruction. You don't have another way. Okay, guys. So now for an instruction here, look here. Bit clear, bit set, branch. Look, branch clear, branch set. Yes. But wait a second. Look here. I told you there is some advantage. There is some advantage here for AND over this one, right? Because AND you can make the branch long, but for this one it has to be short. Now you are telling me I can use bit set, bit clear, or I can use logic OR, or I can use logic AND. Is that okay? Is there any advantage for using OR than this one? The answer is no. If you are dealing with memory location, both of them should be the same thing. Okay, maybe this one has only one minor advantage. If you want to do, because this one can only work for memory locations, Okay, so this one, but this one can work for registers as well. Okay, but anyway, I think most of the time we are gonna manipulate addresses. Okay. So anyway, so what I'm saying, this one can only be used if you want to manipulate memory location. Okay. And someone can ask me, but anyway, I'm going to explain in details in chapter 3. But the thing is that every port here should have an address, like a memory location. You know what I'm saying? So when I say memory location, I mean also ports. Although they are not a part of the memory, but still I'm gonna treat them like memory, right? Because they have addresses like memory locations. You got what I'm saying? Anyway, forget this one for now. I'm gonna explain it later in chapter 3. But what I'm saying now, this bit set can be only used, it cannot used for a register to manipulate a register. It can only used for a memory location. This one can be used for both. Okay. Anyway, this may be the only difference. Now let me, I'm gonna give you more details. Okay, how? So what I'm gonna explain right now is how can I check some bits using AND and also using branch if clear, branch if set. Also, why or how I can set some bits using or bit set. How I can clear some bits using bit clear or AND. The only way we have to flip some bits is using XOR. The only way. Okay. But let me tell you something important. Why something logic? Okay, here. Why OR is used if you want to set some bits, and AND is used if you want to clear some bits. Why XOR is using for flipping? Okay, let's go back and see how they work. This is the truth. This is the truth table for AND. If you see here, guys, 0 and X, I'm gonna get 0. 1 and X, I'm gonna get X. So this is the case of no change. This is the case if you want to clear some bits. Okay, that means if I have a byte and I want to clear this bit, so I have to put 0 here, and now I don't want to. I don't want to change the other bit, so I have to put once. And then you have to do logic AND. So what I'm gonna get here, guys, I'm gonna get this part is gonna be exactly here, but here I'm gonna get 0. You got what I'm saying? Again, what I'm explaining here, guys, why AND is used if you want to clear some bits. Why? Because as you see here, if you put 0, you clear the bit. If you put 1, no change. And this is exactly what I want to do. Some bits, no change. Some bits I want to clear. That's why this one is used if you want to clear. If you see how OR is working, if you put 1 in a certain bit, you actually are going to set. But if you put 0, no change. This is how it works, right? No change. Because 0 or any bit, you're going to get the same bit. Okay? That is why if I have a byte and I want to set this bit. No change here. No change. Very easy. All what I'm going to do, I'm going to put here zeros, guys. And then I'm going to put here 1. That's it. So when you put here 1, I'm going to get 1. 0, no change. So whatever here is going to come to here. So I got the same byte. But this bit, I'm going to put 1. Then everything is the same. Any questions? Same thing. If you look how XOR can be used to flip some bits. Okay. Look how it works. 0, 0, and a bit, no change. You're going to get the same bit. So 0 is going to make no change. 1 is going to make a flip. Again, that's how XOR works. In case of XOR, this is the truth table of XOR. This is how, when they invented XOR, they told us XOR is going to work this way. Okay. So very simple. If I have a byte and I want to flip this bit and no change here, very simple. The bit I want to change, I'm going to put 1. The bits you don't want to change, I'm going to put zeros. Then I'm going to do XOR. Okay, guys. The part that may be confusing to students, but you should understand it. The part that may be confusing the students is here in case of AND, 1 means no change. Here, 0 means no change. Here, 0 means no change. So the bits you don't want to change here, you have to put 0, but here you have to put 1. And this is how it's related to how they are working. You got what I'm saying? In case of XOR, 0, no change. Anyway, any question, guys? Okay. So this is now let's go to that's what I'm explaining here. Okay. Now let's come to the first part. Very important. We will do it all the time. How can you check if a bit is 0? Okay. Look at the idea, guys. Okay. I'm going to explain it in two different ways. Okay, I'm going to explain branch if clear, branch if set. I already explained this one before, but I'm gonna say it again. And now I'm gonna explain it. How can you do it using logic AND? Okay, so this is how can you check if a bit is 0 or 1. So let's see how it works. Look at the logic. What's important here, you should understand the logic. Look here, guys. I want to check this bit. I want to check this bit. So the way I'm gonna do it, guys, is the bit I want to check. I have to put 1 in the location of this bit. The bits I don't want to check, right? So I have to put 0 here. Why? What is the logic? I'm going to tell you what is the logic. So idea here is when you put 0 here, and this is AND, so I'm going to mask this part. Mask means it's going to be 0, 0, 0, 0. Okay. And because this is to look at the result I'm going to get here, guys. So the result I got this bit is here. Okay. And then I'm going to get 0, 0, 0. So I'm going to get a byte. This byte has 0, 0, 0, 0, and only 1 bit. Is that okay? Now I'm going to check the value of this byte. If the value of this byte is 0, that means the bit 7 is 0. If the value is this byte as a whole byte, if the value of this byte is not 0, if I compare this byte to 0, right? So if the value of this byte is not 0, that means bit 7 was not 0. Why? Because I cleared all the other bits. That's what I did. I cleared all the bits except 1. So the only way to make this byte 0 is when this bit is 0. You got what I'm saying? So that's exactly what I'm gonna do, guys. Look at the logic. Number 1, if I want to check this bit, guys, here, I have to do AND operation. After I do AND operation, I can compare this byte to 0. If this is equal to 0, if this one is equal to 0, that means the bit was 0. If this byte is not equal to 0, that means this bit is not 0, it is 1. You got what I'm saying? So number one, you can do AND operation. And then I'm gonna compare, I can compare this one to 0. Then I will see if it is equal or not. If this byte is equal to 0, that means the bit is 0. Otherwise, the bit is 1. Okay, guys? Actually, this compare is redundant. You don't need to compare here. Okay, if you want to put compare, that's okay, but it's just redundant. Why compare is redundant? You don't need to compare, guys, simply because this AND operation is going to update the 0 flag. So if the result is 0, automatically this AND is going to put the 0 flag is 1. If the result of the byte, if the value of the byte is 0, so this AND is going to put 1 in the 0 flag. Otherwise, it's going to put 0 in the 0 flag. So actually, you don't need to compare to 0 because this AND is going to update the 0 flag. So all what you have to do, just very easy. All what you have to do, guys, number one, you have to do this logic AND. After this one, you have to say you branch if equal or branch if not equal, which one. So for example, if I use branch if equal, that means if the bit is equal to 0, you are going to branch. If you want to branch, if the bit is equal to 1, you have to use this one. Very easy. So number one, you have to do AND. After AND, you are going to use branch if equal or branch if not equal. One of them. It depends on what you want to do. If I want to branch, if the bit is 0, use branch if equal. If you want to branch, if the bit is 1, use if not equal. You don't need to compare. If you want to use compare, you're not very confident, that's okay. It's just redundant, and that's okay. I'm not gonna for sure, as long as I told you, as long as it works, it's okay for me. Even if something is redundant. But again, you're still in the beginning, you are learning, but you should also keep in mind what I'm saying here. You don't need to compare, but if you want to do it, that's okay. Any questions? Okay, let's have an example. So tell us. So this is how I'm going to give you examples, okay? But this is how you have to do it if you want to use logic AND. If you want to use logic AND, you have to do it this way. I'm going to show you examples, okay, guys? So the way you have to do it, The bits you want to check, you have to put 1, and the bits you do not check, you have to put zeros. Is that okay? Now I want to make a quick revision on branch if clear, branch if set, okay? Because this is the other alternative, okay? So we have here, as I explained before, branch if clear. And then you have to tell me which memory location. So you have to give me an address here. And then you have to give me a mask. And then you have to tell me where you want to go. Like, for example, next. You remember when I explained it this way? So here you have to give me an address for a memory location. You have to give me a mask. So this mask should tell me which bits. This mask should tell me which bits you wanna check, right? And then where you wanna branch. So the way this one should work is we are gonna branch to next. We are gonna branch to next if when the bits you wanna check are clear. Okay. So how I can do this mask? Okay, I'm gonna tell you what. Very simple. In this mask, you have to mark. You have to mark the bits you want to check. How can you mark it? By putting 1 all the time. Yes, all the time you have to put 1. Don't be confused. Here we are putting 1 and 0 for a completely different thing. Here I'm putting 1 because I want P7. I want to get P7 here. I put 0 because I want to get 0 here. This is a completely different story. But here, this is just here. You have to just to mark it, and then I will take care of it. Okay, just mark it. Okay. So here, for example, if I want to check this bit, so I'm gonna say here, look here, guys, 1 0 0 0. Then I can say 0 0 0. Is that okay? I can write it this way. So when I put this way, please, I want to check this one. That's why it's gonna be the same. If you want to use branch if set, branch of clear, it's gonna be exactly the same way. Because you just here you mark. You just tell me which one. Is that okay? So what's going to happen here, this instruction is going to branch to next if this bit is clear. This bit and this byte is clear. This one is going to branch if this bit is set. You got it? So again, so this is the 2 approaches we have. I can use this one, I can use this one, or you can use this one, and with this one you can use branch if not equal or branch if equal. Got it? Let's see some examples. How can you do it using examples? Okay. So I'm gonna jump here to see what examples we have here. Not this one, not this one. Yeah. Not this one. Yeah. Here. So for example, I want to branch to a location. This location is called next. Okay. If bit 0 of the byte at this memory location is 0. Okay. So let's see if I do branch if clear. So if I use branch if clear, should be this way. I'm gonna say branch if clear. This is the address. This is the address. So the byte. So I'm saying, please, I wanna check the byte at this location. The byte at this location. Is that okay? And this is a mask because I wanna check bit 0. I wanna check bit 0. Okay. So that's why I put here 1. Okay. And then I put next. Yeah. So just 1 instruction. Very simple. Very easy. Very simple. Yeah, so that's what I'm saying. If this one can work with you, just use it because this is very simple. It's just one. It is just one line, one instruction. However, as I mentioned, this one has 2 weaknesses. The first weakness here, this one is short. It cannot be long. We don't have a long. It's only short. The other weakness, this one has to work on a memory location. It cannot work on a register. It has to be a memory location. Okay. Anyway. If it is okay for you, just use it. It's easy. The other way, here I'm going to do AND, logic AND, as I told you, logic AND. So here, in order to do logic AND, I have to write 3 instructions. 3. Look at how I'm going to do it. Number 1, as you see here, guys, I'm going to read the byte. I'm going to read the byte at location number 10, put it in register A. Then I have to use logic AND. Because I told you, if you want to check some bits, the only thing you can use is just logic AND. Okay, and I did that because I don't have one instruction to do AND between memory location and immediate number. We don't have this one. That's why I have to put it in register A first. Okay. So as you see here, guys, and then after that, so now I read the byte, I put it in register A, right? So I read the byte, I put it in register A, And then now I want to check this bit. So I'm going to put here 1. These bits, I don't want to check them. So you have to put 0, as I explained to you before. Okay. And then the result should be B0. So B0 is going to come here, B0, and then 0, 0, 0, 0, 0, B0, and then 0, 0, 0, 0. Is that okay? Okay. And then this byte can be 0 or 1. If this byte is 0, so your bit is 0. If this byte is not 0, so the bit is 1. Okay. And exactly that's what I did. So I'm going to say here, I don't need compare, as I told you. If you want to add here, compare A to 0, okay, put it, but actually you don't need it. Okay, if you are confused, but you don't need it because this AND is gonna update the 0 flag anyway. Okay. So here I'm gonna say branch if equal means I'm gonna go to next when the bit is equal to 0. If I wanna jump, so let me, I'm gonna change it. Look here, guys. Any questions so far before I change it? So what I'm saying here, so here in both cases, in using this one or using this one, in both cases are doing the same thing. What do you mean by the same thing? I mean, I'm gonna branch to a location called next if bit number 0 in the byte 10 is 0. Okay. Any questions? Any questions? Okay, guys. So now let's change the problem. What I want to do right now, I wanna jump to next if this bit is 1, not 0. A 1, not 0. What would I change here? Okay, let's see. Okay, here instead of saying bit clear, I'm gonna say bit set. That's it. I'm done. Very trivial, very easy. Okay. Here, what would I change here? And instead of saying equal, I'm going to say if not equal. Very simple, very easy. That's it. Very simple, very easy, right? So here, I'm going to jump if this bit is 1. Here, I'm going to jump if the byte is not 0. And the byte is not 0. When this bit is not 0, it's 1. Any questions? Any questions? Okay. Okay, guys, is that easy? Okay, now we have a small problem here. What is the small problem? I'm going to tell you what's a small problem. You remember when we did, remember why we had compare? What compare is doing? Compare is doing subtraction, as we did before, subtraction. But what we didn't use subtract, we used to compare. So we know the difference between compare and subtraction, right? Compare is going to do subtraction, update the flags, but it's not going to store the result anywhere, because I want to use compare just to update the flags. I'm not interested in the difference. I'm actually, I don't want to do subtraction, get the difference, use the difference. No, I just want to do subtraction, update the flags. That's why we have compare. Is that okay? That's why we usually we don't use subtraction, because subtraction is gonna change. If you want to compare a register to a value, subtraction is gonna change the value of the register, right? We have the same situation again here. We have the same situation here again. Look here, guys. What's gonna happen here in this instruction? This instruction is gonna do AND operation. So this instruction here, guys, this one is gonna do AND operation. It's gonna update the flags, and then it's gonna store the result in A. This is what this instruction is doing. So this is what this instruction is doing. It's gonna do AND operation, update the flags, store the result in A. Right? Do you want to store the result in A? Do you want to destroy A? No, the answer is no, because I'm not interested in doing AND and getting the result of AND and use it. No, I'm not interested in that. The reason I'm doing AND just to update the flag, similar to compare. You got what I'm saying? So again, that's why they created, similar to the idea of compare and subtraction, they created another instruction. This instruction is called bit A. So bit A is gonna do exactly same thing like AND. It's gonna do AND. Bit A, this one is gonna do AND. Gonna update the flags similar to AND, but it's not gonna store the result anyway. Similar to compare. You got what I'm saying? So compare and subtraction, it's the same idea we have right now with AND and bit A, right? So again, again, if it's okay for you, if you want to destroy A, it's okay for you, that's okay. If it's okay, you can use this one. However, if you use this one instead of this one, okay, you can say just bit A 0, 1. So this instruction will do exactly same thing, because this is for comparison. I just want to do update. I want to only update the flags. I don't want to put the result in A. So you can just use this one and you are okay. Everything is okay. So this is a new instruction. We call it bit A. So actually we have two of them. So we have bit A and we have bit B. That's it. That's all what we have. So as I'm explaining here, guys, bit A, and then you can put here a memory location or immediate value. So what this one is doing, actually, you are going to do AND. I was going to update the flags. And A, same thing. This one is going to do AND, update the flags, and to store the result in A. But this one doesn't store the result anywhere, because I'm not doing AND because I'm interested in the result. No, I just want to update the flags. I just want to do comparison. I want to check. Okay. Anyway, so we have bit A and bit B. Okay. But this one for AND A, this one for AND B. Any question, guys? Okay. So before, maybe I have more examples here. I'm going to teach more examples. Let's have more examples. But the conclusion is, guys, the conclusion is, if you want to check some bits, now you have two options. Either use AND, and after AND use branch if equal. So this one is going to branch if the bit you want to check is 0. Or you can use branch if not equal. This one is going to branch if the bit you want to check is 1. Okay, this is one option. The other option, you can use branch if clear, or you can use branch if set. That's it. Okay. To understand the difference between the two approaches is branch if clear, branch if set always short, and always they work for memory locations. They can't work on register. But this one you can work on, for example, on register. Anyway, and also you can make it long. Look here, guys. That's why here I'm putting L here. I can make the branch long. Anyway, let's have more examples. Yeah. So for example, I want to do something like that, guys. I want to branch to next if either bit 0 or bit 1 in memory location 10 is 1. So this is memory look. This is the address number 10. And I have a byte here. In address number 10. I want to check 2 bits, not 1. I want to check these 2 bits. Okay, guys? These 2 bits, there are 4 cases here, as you see here. I have case 0, 0. I have case 0, 1, 1, 0, 1, 1. So this is the 4 cases. Is that okay? So here I'm telling you if either any one of them, either here means any one of them is 1. That means this case. So I want to jump to next if I'm here in this case. If either any one of them is 1, right? At least one of them is 1. Look what I'm saying. So this is this case. Okay. So look here the idea, guys. If I do AND and I put 1 here. If I do AND and I put 1 here. Okay. And then I put here 0, 0, 0, 0, 0, 0. Okay. So and then the result, if the result is 0, okay, if the byte, the result I got is 0, that means the 0 flag is 1. Okay, that means both of them are zeros, because actually what I'm gonna get after you do this AND, what you are gonna get here, guys, is actually B0, B1, and then 0, 0, 0, 0, 0, 0. Okay, this is the byte I'm gonna get. So the only way this byte can be a 0 when these 2 bits are zeros. Is that okay? So that's why if I use after I do AND, if I use branch if equal, so this one is gonna branch if the 2 are zeros. If I use branch if not equal, so this one is going to branch in any one of these cases. Okay. And actually, that's what I'm asking you to do. So what I'm asking you to do, I want to branch if this is the case. That's why I did this way. So look how I made it. I'm going to say, I'm going to read the byte. I'm going to put it in register A. And then I'm going to say bit A. Bit A means I'm going to do logic AND A and this number here because I want to check these 2 bits. And then I'm going to say, if it is not zero, please go to next. Okay, so this one is going to, this branch is going to be taken when the 2 bits are any one of these values. However, if the result is 0, so this branch is not going to be taken. If the result is 0, this branch is not going to be taken, and then we are going to come this way. And this is going to happen when the 2 bits are zeros. Okay, guys? Okay. Okay. If I want to use branch if clear, branch if set, okay, how it can use it? Okay. Branch if clear. So this one is going to branch if the 2 bits, both of them are 0. It's not going to branch if this is the case. Branch if set. This one is going to branch if all the bits you want to check are ones. Otherwise, it's not going to branch. You got it? This is how they are working. Okay. If I'm going to branch if all the bits I wanna check all of them are zeros. Or the other one, I'm going to branch if all the bits are ones. Okay. So if I want to do the same thing, okay, if I want to do the same thing similar to what I do here using branch, look here, guys. So I wanna branch to next in this case. Okay. So what we have to do here is what we have here, we have branch in case of this one is going to branch in case of 0, 0, right? And it's not going to branch in this case. So what's going to happen is, look here. If I want to do, I'm going to say, if I want to do it in a different way, look what I'm going to do. I'm going to say branch if clear, if it is 0, 0, if it is clear. Okay. Then I'm going to say 10. Then I'm going to say the mask is 0, 0, 0, 0, 0, 0, 1, 1, and then go to something we call it out or skip, whatever you want to call it, skip. So that means if both of them are zeros, come to here, and here is a skip. And here should be next here. Why? Because I'm going to come this way when the 2 bits are 0, 1, 1, 0, 1, 1. But I'm going to come this way when the 2 bits are zeros. I'm going to skip. So next should be here. You got it? Any questions? Let's have more example. Okay, for example, this example is somehow interesting. This example because look here, guys, how this one is different. This one is different. Why it's different? I'm going to tell you. See how it works. I want to branch if the 2 bits are 1 and 0. I have 2 bits. I want to branch when this bit is 1, when this bit is 0. This is different because all what I did before was the 2 bits, all of them are zeros, all of them are ones. That's the instruction we have. So the instruction we have, I can branch if all the bits you want to check, all of them are zeros, or all of them are ones. We don't have an instruction to branch if one of them is 1 and one of them is 0. That's why I have to do it. I have to check 1 by 1. So I have to do it twice, as you see right now. So the way I'm going to do it right now, guys, is that look how I'm going to do it. I'm going to check. First, I'm going to check this bit. I'm going to check this bit. If this bit is 1, okay, that means go to end, right? Because I don't need to check the second one. That means the condition is already false. And that's exactly what I did here. Look what I did here, guys. I'm going to check the first bit. If the first bit is 1, please go to end. Okay, so the condition is false. It didn't happen. Okay. However, if this bit is 0, so it's not, so this branch is not going to be taken because this branch is going to be taken when the bit is 1. When it is 0, I'm going to come this way. When I come here, so the first condition is true. Now I'm going to check the second condition. I'm gonna say, please, oops, I made a mistake here. This one has to be 1, this one has to be 0. I'm sorry. Okay, because here I have to check the first bit, here I have to check the second bit, right? So now I finished the first bit, now I want to check the second bit now. Okay, I'm gonna say if the second bit is 0, the condition is false. So I'm gonna say just skip, go out if it is 0, right? So if this branch is not taken, what it means? It means 0 and 1. Okay, so I'm gonna say here, I'm gonna say if P0 is 1, just come here. Or if P1 is 0, come to here. The only way to come to this point to here, when the 2 branches are not taken. And these 2 branches are not taken when the first bit is 0 and this one is 1. Did you get the logic? Here you should understand why I need 2 different instructions here. Why I need this one? Because the instruction we have are gonna check if all the bits are 0s, all the bits are 1s. But here I want to make sure this condition is I want to go somewhere or I want to do something when this one is 0, this one is 1, right? So I have to check one by one separately. That's what I did. Okay, guys, any questions? Great. So now I am done with the first part here. As I told you today, guys, we have 2 parts. One part is how can you check some bits? How can you check some bits? Okay, this part, I am done with this part. I already explained the 2 approaches. How can you use branch if clear, branch if set, and how can you use logic AND. Is that okay? Now I want to move to the second part. How can you do bit manipulation? Okay, and for bit manipulation, as I told you, if you want to do set, you have bit set, or you have to use logic OR, as I'm going to explain right now. For flip, the only option you have to use XOR. If you want to clear some bits, we have an instruction, we call it bit clear, or you have to use logic AND. That's it. So I'm going to explain how can you use bit set, bit clear, how can you use OR and AND, and how can you use XOR to flip some bits and don't change the other bits. Okay, let's see. Okay, let's see here. Okay, let's first explain. Yeah, let's explain how bit set and bit clear is working. Okay, look here, very simple. Bit set is used if you have a byte. This byte is a location in memory. That's number 1. Number 2 is used if you want to set some bits and you don't change the other bits. Bit set. Bit clear if you have a byte in memory, right? And you want to clear some bits and don't change the other bits. Okay. And this is how the instruction should be written. Here you have to give me address, the address of the byte. You have to give me address of a byte. Okay. So once I get the byte, now I'm gonna set some bits. I'm gonna clear some bits. Okay. But which bits? You have to tell me. You have to tell me which bits you want to set, which bits you want to clear. You have to tell me. How you can tell me? Using a mask. Using a mask. And similar to what we did before in the mask, the bits you want to manipulate, you have to put 1 in the location of these bits. For example, here, the bits you don't want to change, you have to put 0. For example, if I wanna change this bit, I'm gonna put 1. I don't want to change this bit, you have to put 0s. This way. Okay. Again, you can write it in binary, or you can write in hexadecimal, by the way, as well. Both of them are okay. Or in decimal, whatever you do, it doesn't matter. Okay. What if I want to change more than 1 bit? Okay, just put 1 here. So in this case, I'm gonna clear this one. I'm gonna also clear this one. Okay, that's it. Very simple. So let's see some examples here, guys. I have the byte at location number 10. Look how this instruction is working. Okay, the byte at location number 10. This byte, I'm gonna set this bit, and then the other bits not change. So that's exactly what this instruction is gonna do. So this instruction, I wanna set the bit number 7 in the byte in this location, and then the other bits not change. Is that okay? What if you want to clear? Very easy, just a bit clear. Okay, so what's going to happen here? It's the same thing. the byte at the location address number 10. In this byte, I want to clear bit 7, and I don't want to change the other bits. Okay, guys, I can just use this one. Very easy. Okay, guys, any questions? Very easy. And this one is exactly similar to, you know what is the difference between one and the branch of set and branch of clear? Similar. So this one branch of clear or branch of set, I have to do this part. I have to do this part, but I have to add one more for the label because you want to jump. So the two instructions are very, this is confusing to students because these two instructions, they are close to each other, but they are completely different. They are doing something completely different, right? Even the writing, look here, be set, BR set, BR clear, be clear. So writing is very close, okay? But they're doing something completely different. These two are gonna check bits and jump if some bits are ones and zeros. But these two instructions are gonna manipulate bits, okay? Any questions? Okay. So now the question is, okay, you told us I can use this one all the time. Yes, you can use this one all the time. Okay. The other option you have, you can use logic OR to do the same thing. If this one works with you, this is just simple. Just use it. I'm totally fine. Just use it. But just in case, for some reason, if you want to use, I want to explain the other option. Okay. The other option, you can use logic OR. For this one, I have to use logic AND. Okay. How can we do it? Using OR and AND. I'm going to tell you how. Look here, guys. Let's do this one first. Okay, look how I'm going to do it here. Come to here. Okay. So number one, I'm going to say load register A and 10. So I'm going to read the byte. At location number 10, store this byte in A. Why? Because I want to do logic OR. And logic OR is only done on register A and B. I don't have other option. Okay. Then I'm going to say OR A. I'm not sure if it is double A. I think it's double A. You can check it. You can check it if it is double A or 1A. I think it's double A. Yeah, double A. Or A, okay, guys. And then now the bits, and then you have to put here immediate value. Okay, which bit you want to set 1? The bit you want to set, you have to put 1. The bit you don't want to change, you have to put 0. This is how OR works. Okay. So, and then now the result is in A, so I have to return it back to 10. You got what I'm saying? You got what I did here? So I'm gonna read the byte. Then when I do OR, this one, bit number 7 is gonna be 1. The other bits will change because this is how OR works. 1 is gonna put 1. 0 is gonna make no change. Then I'm gonna store it back in 10. Any questions? Okay. Now, how I can do this one? You told us if you want to clear some bits, I can use this one or you can use AND. Yes. So how can you do it? Okay, I'm going to tell you how can you do it using AND. Same idea. You have to do load register A 10. So I have to read the byte at the location 10. This number 1, right? Then I'm going to do AND A. I think it's AND A. Let me see the writing. Yeah, it's AND A. It's 1A. Okay. So it's AND A, right? And then here is different. Here, the bit you want to clear, you have to put 0. The bits you don't want to change, you have to put 1. Why? Simply because this is how AND works. This is how AND works. 1 is gonna make no change. 0 is gonna clear. This is how AND works. Here, in case of OR, this is how it works. 0, no change. Anyway, and then I'm gonna store A in 10, in location 10. Okay, guys. Any questions? 2 different ways. If you like, if this one works, yeah, I love this one. All the time I'm gonna use this one and this one, by the way, because it's just easy. Why I write 3 instructions if I don't need 2? Right? But I'm gonna just explain it in 2 different ways, just in case you need this one for something. But if this one works, just use it. If this one works, just use it. Okay. Any questions? Good. So here I just give you more examples here, guys. I wanna clear the upper 4 bits. I wanna clear the upper 4 bits in this byte. Okay. So the way I'm gonna do it, I can do as I told you, bit clear 56, and then I wanna clear these 4 bits. So I'm gonna put 1 1 1 1 0 0 0, right? Because I need to mark. You need to mark. You have to tell me which bits you wanna clear. Okay. You can write it in binary this way, or you can put it in hexadecimal this way. So okay, this one can work. This one is okay. The other approach I can do it, as you see here, guys, I can read a byte, and then I can do AND with this one. Oh, how you made it? This one is different from this one. Yes, they are different, because here always here the one is gonna mark. You need to mark which you need to identify which bits you want to clear here. Okay, but here no. Here this is logic AND, and I know from logic AND 1 means no change, 0 means clear. That's why, because I want to clear this 4, so I'm going to mask this 4, I'm going to clear them, and then put 1 1 1 here, so that no change in these 4 bits, and then I'm going to put back in 56. Okay, guys. One more example. Any questions? One more example. Bit 7, I want to set bit 7 in the byte at 10. Okay, so this is one way I can do it. Bit set, okay, 10, and then 1 0 0 0, as you see here. Okay, so this instruction, the byte at the location 10, I want to set the most significant bit and no changes to the other bits. Yeah. Okay. The other approach I can do it, I can read the byte. I can read the byte at location 10, and then I can do OR. And I know in case of OR, 0 means no change. The bits I don't want to change, I'm going to put zeros. The bits I want to set, I'm going to put 1. That's why I put it this way. And then I'm going to store the result here in 10. You can write this one in binary, or you can write it in hexadecimal this way. Any questions? Yes. Yeah, it's coming now. So I'm going to explain now the other, because I explained how can you set some bits, how can you clear some bits. But now I'm going to explain how can you toggle some bits. Is that okay? In case of toggle, we have only one option. We don't have like, here we have 2 options. You have bit set, you bit clear, or you can use AND or OR. But in case of toggle, you only have, you have only one XOR. This is the only, we don't have something like bit set, bit clear. We don't have bit flip. We don't have this instruction. Okay, so that's why the only way you have to do it using XOR. So let's do here in XOR. That's the example. I want to flip bit number 7 in the byte at location 10. Is that okay? So this is the byte at location address 10, okay, or location 10. I want to flip this bit, and I don't want to change this bit, no change. Okay. So again, I did not invent it. If I didn't invent XOR, I just use XOR. So try to see how XOR is working. So if I go back and see how XOR is working, here, guys, look here. I did not invent XOR. So this is how XOR works. Okay. If you put 0, no change. 0 is gonna make no change. 1 is gonna make flip. Okay, I'm gonna just use it. Okay. So the bits I don't want to change, I'm gonna put 0s. The bits I want to flip, I'm gonna put 1. That's it. Very simple, right? That's exactly what I'm gonna write now. Oh, sorry, I think I missed it. Yeah, here, guys. Look here, guys. Here in the question, I'm asking you to flip this bit and don't to change the other bits. Very simple. So this is how XOR works. The bits I don't want to change, I'm gonna put 0s. The bit I want to change, I'm gonna put 1. That's it. That's it. So once you do that, 0 means no change. So whatever here is gonna come here. No change. 1 means a flip. So if this is bit 7, you are gonna get here bit 7 prime. This is how XOR is working. And that's exactly what I did here. So what I did here, guys, I'm going to say, read the byte in location number 10, put it in register A, XOR with this number 180, which is 1000000. So I want to flip last one and just don't change the other bits. And then I'm going to store the result back in location number 10. Any questions? Yeah, sure. EO. Oh, okay, maybe let me check. Sometimes right. It's EORA, as you see here. EO. Anyway, that's okay. Don't worry. If I make any misspelling, I put. If you go to the slides here, I summarize all the instruction in tables. So just easy. You can go to the table and see how the writing. And also CodeWarrior is going to give you error anyway. So CodeWarrior is going to tell you, I don't understand what this instruction is if you do any misspelling, right? Yeah, sometimes I mix mistakes here, as you see here. You got what I'm saying? So already summarized here. That's what I do for all instructions. They are summarized in tables. Okay. Okay. So what else do you have here? I just have a couple of examples, and that's it. Okay. Yeah. So here I just have a very interesting example. I'm assuming, let me go to the chapter here. Yeah, some fancy example, interesting example. I'm assuming here, guys, we have a car. I'm assuming we have a car here. And in this car, we have a port. This port at location number 0. This is what I'm telling you. I have a port at location number 0. And then I'm telling you if the right door, so this one, this bit number 6 can tell you if the left door is open or closed. Bit number 5 is gonna tell you if the right door is open or closed. Bit number 4 is gonna tell you if the tank door is open or closed. Okay, and then this is the cabin light. This bit should turn the cabin light on and off. You got what I'm saying? So here I have some bits. So if this bit can tell me if the left door is open or closed. This one is can tell me if the right door is open or closed. This one is telling me if the tank door is open and closed. And this bit can turn the cabin light on and off. Right? So now I'm gonna give you several questions. I'm gonna ask you, I'm gonna tell you, if the right door is open, turn the light on. Okay. So now if the two doors are open, turn it on, and so on. So I'm gonna give you some conditions here. Okay, so and then these conditions, there are some bits you need to check, and based on the value or based on the result of this check, I'm going to turn the light on or off. Okay, so for example, I need to check the right door or left door, and then based on the result, I'm going to turn the light on or off. Yes. ask the people who design the car. So or anyway. This is just an example, okay? Just an example, okay? So the guy who do the programming, he did it this way. Just an example. We're not going to even use it, okay? So in the example right now, I'm going to use. This is just an example. It's not a real car, okay? Anyway, so let's see the examples I have right now. So now we have a byte. In this byte, now I have a byte. In this byte, I wanna check some bits. And based on the value, based on the result, I need to manipulate one bit. So that's what I'm explaining here, guys. Look here, guys. Bit number, again, this is a byte at location number 0. Okay. Bit number 5, if bit number 5 is 1, that means the right door is open. If it is 0, if this bit is 0, that means the right door is closed. If bit number 6 is 1, that means the left door is open. If it is 0, 0 means it's closed. Okay. You don't need to worry about how it became 0, how it became 1. Don't worry about that. There is a sensor. This sensor hardware, the hardware is going to put 1 or 0. Just when you find it is 1 or 0, you cannot open or close. But the hardware is going to put the 1 or 0. The hardware will do that. Okay. So now this bit, if I put 1 in this bit, I'm going to turn, sorry, I think if I put 0, I'm going to turn on in this bit. If I put 1, I'm going to turn the light, the cabin line off. Okay, so 0 for on, 1 for off. Okay, so let's see now. I'm going to give you several logic and ask you to program it. Okay, now I'm going to tell you, turn the light on if the two doors are open. Both of them are open. So if these two doors are open, please turn this one on. Okay, what it means? It means open means 1. That means if we have here 1 and 1, so I'm telling you, if you have here 1 and 1, you have to put here 0. That's what I'm telling you. If the two doors are open, maybe this doesn't make sense, okay? Because usually the light should be on if one door is open, but I just wanna play. I just wanna play with it. I wanna program different logic, okay? So if the two doors are open, so that means if you have here 1 and 1, so you have to put 0 here. Otherwise, put here 1 to turn it off, okay? So let's see how I made it. So the way I made it, guys, very simple. I wanna check if these two are 1 and 1, right? I want to check these 2 bits. That's exactly what I did. So I'm going to say branch if set. If these 2 bits are 1 and 1, please, okay, in this location, in this memory location, and these are the 2 bits I want to check. This is the mask. So I want to check these 2 bits. If these 2 bits are 1s, okay, please, I want to turn the light on. So I'm going to branch here if the 2 bits are 1 to assert a location here, and in this location I'm gonna bit set. I think I made a mistake here. I think 1 for on, 0 for off. Anyway, you can program it either way. Anyway, it depends on the hardware. Okay, but anyway, so here I think I'm to be consistent with the example here. So 1 for on, 0 for off. Anyway, so what's gonna happen? I'm gonna check these 2 bits. If the 2 bits are 1 and 1, I'm gonna come here. Once I come to here, I have to turn the light on. So I have to put 1 here, but using bit set, as you see here. I'm gonna say bit set 0, 0, 0, and then I want to turn this one on. Okay, bit set. If not, if this branch is not taken, that means I'm gonna come here, guys. If the 2 bits are 1 and 1, any other case, I'm gonna come this way. It's very important to understand the logic here. I wanna look at the 2 bits. If the 2 bits are in case of 1, 1, I'm gonna come this way. Any other case, what do you mean by any other case? I mean any one of these. I think something is wrong here. I'm sorry. This is 0 and 0. I'm sorry. This is 0 and 0. This is any other case. So in case of 1, 1, I'm gonna come here. Any other case, I'm gonna come here. And in this case, I'm gonna turn the light off. How can you turn the light off? Bit clear to turn it off. Very important. Don't forget to skip this part. Many students forget this one, because once you turn it off, you have to skip this part. Otherwise, if you forget this one here, every time you are going to turn it on anyway. No matter what, you are going to turn it on. You got what I'm saying? So if I come here, guys, if I go this way, I have to do this one, and then I have to skip. Is that okay? Makes sense. Any questions? Any questions? Let's have more examples. Let's have another logic. In this logic, guys, I'm telling you, I want to turn the light on if either door is open. Either. Okay. Either means this case. So now I have 2 bits, right? I have 2 bits, bit 5 and bit 6, right? To know if door is open or closed. Here, if the two doors are closed, this is the case. So here both of them are closed. So I'm gonna get 0, 0. Here, at least one of them open. Okay. So here I'm telling you guys, if either one of them is open, so it means at least one of them is open. In this case, I want to turn the light on. Otherwise, turn the light off. Okay, how can you program the logic here? Okay. Keep in mind, the tools, the instruction I have, they can look for both of them are zeros or both of them are ones to branch. Okay. So if I say branch if clear, and that's exactly what I'm gonna do right now. So I'm gonna branch if both of them are clear. Otherwise, I'm not gonna branch. Okay. So let's see. So what I'm gonna do right now, guys, I'm gonna say, look here. Branch if clear, these 2 bits. So if the 2 bits here are clear, in case of 0, 0, I'm gonna say, so in case of 0, 0, if both of them are clear, I'm gonna come here. If not, if any other case, so I'm gonna come here. Okay. So because you are here, so you have to turn the light on. To turn the light on, you have to use bit set, as you see here. So you have to set this bit. Okay. And then I have to skip this one. Please don't forget this one. You may waste hours to debug your program, to figure out what's wrong with your program if you forget this one. Because if you forget this one, you are gonna come here no matter what. Okay. What I have to do, if I execute this one, I should not execute this one, right? So I have to skip. After this one, you have to skip this one. Okay. So anyway, so what I'm saying here, guys. Okay. So now, if both of them are 0, 0, so I'm going to use bit clear in order to turn the light off. Any questions? Logic. See the logic. Okay. When you are going to branch, this is the best way to understand this part, guys. Look at the logic. Here I'm going to branch if both of them are zeros. If not, what do you mean by not? It means in any one of these. So if the branch is not going to be taken, I'm going to come this one. Okay. And in this case, I have to do this one. In this case, I have to do this one. And I have to skip this part to avoid, because if I execute this one, I should not do this one. Only one of them should be executed at a time. At a certain time, only one of them. Only one of them. One more. Any questions? Okay, one more example. I want to turn the light off if both doors are closed. Okay, so now that's a very easy one. So what I want to do right now, if bit 5 and bit 6 are 0, 0, that means the two doors are closed. I want to turn the light off. Okay, that's very easy. So here, I'm going to say branch if clear. These two here. So if these two bits are clear, so please, it's going to come to here. Okay, clear, in order to turn the light off. Turn the light off using bit clear. Okay, if not, so any one of these values, I'm gonna come here and then I'm gonna skip this one. Any question? Great. So in the lab, in the coming lab, number one, we're gonna have a lab on logic operation and shift and rotate. Shift, rotate, logic. Okay, very easy. Also, we're gonna have a quiz on these topics: shift, rotate, logic operations. Is that okay? Very easy. Any questions? Okay, great. So now we are very close to finish this chapter. In this chapter, we only have 2 topics are left. One topic is about the stack. What is stack? What is a stack? How can we use the stack? As I told you before. The other topic is about subroutines. How can you make a subroutine? And that's it. Okay. So let's start with that's it. So we are very close to finish this chapter and then go to chapter 3. I just want to tell you guys, I hope that chapter 3, 4, 5 usually they are more interesting than chapter 2, because chapter 2 is mainly programming. But starting from chapter 3, we're not gonna use the simulation. The last time we're gonna use the simulation is the coming lab. After the coming lab, we're not gonna use the simulation anymore. You have to use the board. That's why we're gonna distribute the board starting from the coming lab. Okay. Why? Because starting from chapter 3, we're gonna start using the input-output devices. So the simulation is not gonna help us. We need the board itself. And usually students like chapter 3, 4, 5 because chapter 3, 4, 5. I'm not going to teach you programming anymore. So I'm not going to teach you. I'm going to just use. I'm going to use what I explained in chapter 2 in order to explain how can you program this one. How can you program this one? So I'm not going to teach you instructions. That's what I'm saying. So I just want. I'm going to use what I explained here. Okay. Anyway, so now we almost have 2 minutes. So in these 2 minutes, I can say something about a stack. Okay, what is a stack? So let's see how I define it here, guys. A stack is a part of the memory that is reserved for a special purpose. Very clear. So I'm going to take a part of the memory. I'm going to call this part of the memory stack. Is that okay? But this stack is used for a special purpose. Okay. So now what we did so far, guys, I told you in our memory, what I told you so far in our memory, we have starting from 1000, we are going to have data from here. And the code starting from 4000, we are going to have a code this way. So until now, what we did, I divided the memory between the data and the code. Is that right? No, now I'm going to add a stack as well. So in the memory now, there should be 3 pieces. One part of the memory for data, one part of the memory for stack, and one part of the memory for the code, right? How we are going to do it? I'm going to tell you how. Look here, guys. Starting from 4,000, the code is going to go this way. Starting from 1,000, your data has to come this way. So every time you add more arrays, more variable, you are going to start from here and you are going to go this way. Where is the stack? Stack, I'm going to start from here and go up. So the stack, I'm going to start from 4,000 and then I go up. Okay. Hopefully that they are in a, they don't collide, okay, or they don't overwrite each other. Otherwise the program is going to crash. So hopefully you don't overuse. Hopefully you don't overuse the stack or overuse the data, and then they are gonna overwrite each other, and in this case your program is gonna crash. But it should be okay. I don't think in our programs, because I don't think in our programs we are gonna use too much of stack or too much of data. But I want to tell you something here, because this is a very basic computer. We don't have an operating system. You are a very basic computer. So it's your responsibility to manage the memory. It's your responsibility to manage the memory. Otherwise, your program is going to crash. What this means, you have to make sure you are not going to use too much stack. You are not going to use too much, or let me say it in a different way. You have to make sure you have enough space for data. You have enough space for stacks. They are not going to overwrite each other. Why? Because this is machine. It doesn't understand anything. This is a low level. We don't have a operating system. If you start writing, it's not going to tell you, no, this is the stack area, you should not write. No, it's going to write. Same thing. If you use too much stack, maybe you are going to overwrite your arrays, your variables, and then your program is going to crash. This is very basic. We don't have operating system. It's your responsibility to make sure you are not going to write too much in the stack, and you are not going to write too much in the data, so that they are going to overwrite each other. It's your responsibility. It happened one time for one student. He came to me and said, look, I did everything. The program is not working. Okay. And when I checked the program, there was some overlap between them. He put it in. There was some overlap between them and this. That's why the program was crashed. Anyway, okay, guys, see you next time.